Peter Kelly-Detwiler, Principal of Northbridge Energy Partners. And in this video chat, we'll continue our discussion of challenges and opportunities facing power delivery leaders at electric distribution utilities. I'd like to welcome back Dennis Elsenbeck, Head of Energy and Sustainability, Phillips Lytle LLP, and longtime leader at National Grid, and Brett Willitt, Senior Vice President of Product at ikeGPS. Brett is one of the leading structural analysis and grid asset management experts in the U.S. Thanks for being here, and I look forward to hearing more from each of you. In our last web chat, we discussed how change and disruption are forcing electric utilities to rethink electric models and processes, especially in the power delivery and T&D function. Dennis, if I can start with you, how do you see the traditional model of grid planning changing as a result of pressures and disruptions such as climate change, load growth, and aging infrastructure?
Yeah, thanks, Peter. It's a great observation. Modeling is changing. So we look back, the traditional model of electric system planning related a great deal to age of the system, number of outages, outage duration, storm hardening processes, and how we can control quality of power from a utility point of view. Utilities also included known economic activity, and they designed to an adjusted peak demand, which in a distribution system occurs between, let's say, 2 and 5 o'clock, which then, of course, impacts everything upstream through area substations, transmission, and supply balancing. Lately, priority has shifted modeling to respond to climate policy, mainly to achieve climate change objectives, renewable energy, and the shift from a fossil to an electric economy, which by some accounts would increase electric demand by 50% or more across many distribution feeders already constrained by capacity and thermal limitations. To stress the impact of climate policy, New York is a good example because New York's line items that the utilities charge for the recovery of climate-related programs on the electric bill is now approximately 60% of the bottom line utility delivery charge. This doesn't even address disadvantaged community revitalization nor demands on the electric system due to market interest in AI, data centers, semiconductors, and advanced manufacturing. So a typical utility has miles of distribution lines, thousands of distribution poles. They're either owned or shared, thousands of substations or pole top transformers. And when climate consultants indicate such an aggressive demand, this places every piece of electric distribution equipment at risk. Without sound data, where does the utility start? What community or neighborhood gets the upgrades in a timely manner? And how do you value potential non-wire alternatives like battery or thermal storage at the point of use? How about microgrids, utility system replacement based on traditional age condition versus the gradual unplanned demand increases due to electrifications of the market? Data needs to be the driver if we're to respond to these new conditions while protecting true system-related costs passed on to the consumer, the ratepayer.
Thanks for painting a picture of some astounding complexity. Brett, how does this impact the issue of overhead distribution asset management? In what ways can data affect how utilities manage their physical assets?
Yeah, no, and to maybe just to some of Dennis's points, I mean, obviously we're seeing, a myriad of challenges when it comes to the physical grid, right? Dennis spoke a lot about, I think, some of the impacts on the electrical side. I mean, it's a two-sided coin. There's the electrical elements of our grid, and then there's actually obviously the physical components, that are supporting it. And while most utilities, you could argue, have really rich data points about the electrical grid and electrical performance of the grid, they also have surprisingly little structural intelligence about the physical assets holding up and supporting the grid. So we're talking about millions of poles representing a really significant portion of their physical assets. So the challenge in my mind isn't just about the data. It's that the engineering, operation, asset management, and planning teams are often working within different siloed systems and using a different set of assumptions. So like, for example, we're unifying and providing a unified structural mechanism and means so everyone can act in a unified way in making decisions about where to invest in the grid. So instead of replacing assets, making assumptions, we're able to provide line of sight that ultimately is allowing them to invest in proactive maintenance and investments in the grid. That's the difference, I think, between planned maintenance and emergency response, because at the end of the day, we can bring this down to both public and worker safety. And it's about helping utilities avoid the liability, service disruptions, outages, and the regulatory scrutiny that can come as a result of preventable accidents related to the physical grid.
Well, thanks. There's certainly a ton here to unpack, and we could easily do an hour and a half webinar on this, but we're trying to keep this short. So I'm just going to ask you each one final question here, well, for both of you. How does adopting a proactive data-driven approach to processes like managing overhead assets impact cost recovery, that rate base, and how the utilities actually go out there and get their investments reimbursed? Let's start with you, Dennis.
Yeah, thanks, Peter. Yeah, the key phrase of your question, in my humble opinion, is proactive. There's a number of lessons to be learned from the results of past utility when we all were doing integrated resource planning. And then energy policies in the more aggressive climate focus and or let's say high growth states, it is inevitable that we start seeing utilities calling for more demand response so that they can methodically upgrade the electric system. We need to be mindful that announcements to delay charging electric vehicles, shutting down businesses during certain demand periods, shutting down air conditionings, these are warning signs that we lost sight of the resiliency of the electric system. A fossil to electric transition is overwhelming the electric distribution system, along with related cost structures. This is where we need more data, as utilities cannot redo the entire distribution system overnight. They need to know where their hotspots are and prioritize their planning to maintain some control of demand profiles, short and long-term integrated resource planning, rate structure, and cost recovery. Additionally, utilities are constantly under prudency reviews via their regulator and in part the legislature with respect to the way they are investing ratepayer dollars. Good and prudent reviews result in a seamless recovery of the dollars invested to ensure shareholder value with a close eye on the unit cost of energy for the consumer. A sound data collection structure in support of a rate filing or regulatory order protects the utility while also providing the most optimum infrastructure plan that balances cost of the ratepayer, maintenance of the shareholder value, and system resiliency despite the externalities of changes in energy policy. Data as close to real time must be the root framework that dictates T&D planning going forward, or we're all traveling blind.
Thank you. And Brett, additional color you'd like to add to those comments from Dennis?
Yeah, no, I'm going to echo a lot, I think, back. I totally agree with Dennis. I mean, I think about, again, kind of from an overhead infrastructure standpoint, poles just aren't infrastructure. They're a core component of that rate base. In the utility pole market, for a measure, the utility pole market alone is valued at almost $60 billion. That just shows the scale of this critical infrastructure. And when utilities can demonstrate the understanding about the useful life or the state of these assets, it strengthens every rate case filing. Regulators, as Dennis said, regulators are increasingly expecting utilities to be able to demonstrate why specific investments are needed now versus later. And then having the structural insight and structural intelligence transforms that conversation into we think to a we know. that includes analytical assessment of these assets. And so by knowing exactly which poles are at risk or where in their system, areas are at risk, they can now bundle investments strategically, maybe at a geographic level or coordinating with other CapEx investment work and avoiding that really premium OpEx reactive maintenance work that we all want to avoid.
Well, thank you. Once again, you've both given us a lot to think about, especially as it relates to that unsung hero of the industry, that humble utility pole we all drive by and don't even see. With the right data and intelligent approaches, we now have new tools to help utilities manage and optimize those costs in the midst of this challenging, ongoing energy transition. So thank you both very much for providing your insights on this really important matter.
Thank you,
Thanks,
Peter.
Peter. Thanks, Dennis.